So let's go ahead and look at this homework here. The first one's a pretty basic antiderivative, so I can't imagine people have too many problems there. Let's go ahead and move on to number 2. So for number 2, we're trying to integrate essentially 7x to the 1/4 minus 5x to the 3/4. So we're essentially adding one of the fractions and then multiplying by the reciprocal. So we would get 7x to the 5/4 divided by 5/4 minus 5x to the 7/4 divided by 7/4. And remember, dividing by the fractions is the same as multiplying by the reciprocal. So this would be the same as 4/5 times 7 times your x to the 5/4 minus your 4/7 times 5 x to the 7/4 plus your c. So this would be 28/5 x to the 5/4 minus 20/7 x to the 7/4 plus your constant. That's what you should get there for number 2. Let's see if it comes out okay. Use capital C. Okay, well, that's very particular. Okay, so they require a capital C for some reason. I've never seen that before, but anyway. Any questions there? Okay, let's have a look at number 3. We're integrating 2u minus u to the 1/3, or the cube root of u, but we really want to write that as u to the 1/3, so it looks like the previous example, number 2. So that is just going to be 2u squared over 2 minus u to the 4/3 over 4/3 plus capital C, which is u squared, and then remember, flip over the fraction and multiply it, so 3/4 u to the 4/3 plus c. Pretty straightforward. Okay. What? This is something's wrong. Use capital C for the. What did I do? Use 2u squared, so add 1 to the exponent, divide by 2. 4/3, 3/4 in front. And 3, use capital C for the constant of the antiderivative. Four over 3. So it should be. Oh, I did a minus for some reason. That's my error. I just put a minus there. It should have been plus. I just wrote the problem down wrong, so all these should be pluses. That's all. Number 4, we've seen a few times something like it. I've definitely done some examples. You just need to split it up over the antiderivative. So for number 4, we're doing the antiderivative of 3 minus 4x cubed plus 6x to the 6th over x to the 6th. We would want to write this as 3 over x to the 6th minus 4x cubed over x to the sixth plus 6x to the sixth over x to the sixth dx. And then remember, this is just going to be the antiderivative of 3x to the negative 6 minus 4x to the negative 3 plus 6 dx. And then we can use the antiderivative rules. So we would have 3x to the negative fifth. Remember, negative 6 plus 1 is negative 5 over negative 5 minus 4x to the negative 2 over negative 2 plus 6x plus our constant. And then we can simplify things again. Probably they want us to use positive exponents. I'll try it just to see if it takes it with negative exponents. And then the two negatives here would make this a plus 2x to the negative 2 plus 6x plus a constant. So my guess is they're going to want the answer like this, 3 over 5 x to the fifth plus 2 over x squared plus 6x plus c. That way we've only got positive exponents, but I'm going to try the previous line to see if it takes it with negative exponents, unless the instructions, because I don't see it saying that in the instructions, but a lot of times that's the way you want it. So indeed, they don't actually need positive exponents, so you can enter the answer with negative exponents. Okay, do we have any questions yet?
I have a question on that one.
Yeah, sure.
Could you scroll up like a little bit on that? I'm just confused a little bit how you got the negative 6. Right.
It's just an exponent rule from algebra. Oops. So the exponent rule says 1 over x to any power is the same thing as x to that negative power.
Okay.
So that's just from algebra. Anything else?
No.
For the other ones, you just subtract the exponents. So 3 minus 6 is negative 3, and 6 minus 6, the x to the 6 cancel essentially, and you just get 6.
Yeah, I just forgot that rule.
That's okay. Okay, so somebody mentioned number 5 explicitly, so we'll do this. We're doing the antiderivative of 9.5 t squared minus 6 over t dt. So we get 9.5 t to the third over 3 minus, remember this is 6 times 1 over t, so that'll be 6 natural log. Maybe they're dinging you if you forget the absolute value of t. 9.5 over 3, that's probably going to be a repeating decimal, so probably you're just going to have to leave it like that. Can't simplify much. I mean, you could make it 19 over 6 if you will, but you know, but here, remember to use absolute values where appropriate. So if you don't use absolute values, it's probably definitely going to mark you off. So since it doesn't say anything about a decimal approximation, we just pretty much have to leave it as 9.5 over 3 t to the third minus 6 natural log absolute value of t plus our constant. So yeah, I don't know. No problems for me on number 5. Maybe you forgot to use absolute value. Number 6, we'll do that one real quick, then we'll get some definite integrals. Number 6, not so hard. We just haven't seen one yet. So the antiderivative of 10e to the 5t dt. So this is just going to be 10e to the 5t over 5 plus a constant. So that's 2e to the 5t plus our constant. Okay. So again, number 7 is a polynomial, number 8 is a polynomial. We've done plenty of those examples, so I'm gonna skip over 7 and 8. We did one just like number 9 too. I mean, does anybody want to see number 9?
I want to see number 9.
Okay. So the integral from 1 to 4 of 4z, and remember, square root is really 1/2 as an exponent. So that's the main thing. So you add 1 to the power and then divide by it. So it'll be 4z. 1/2 plus 1 is 3/2. We're dividing by 3/2. We're going from 1 to 4. Remember, with definite integrals, you don't have to worry about that c. So that's really 4 times 2/3, which will be 8/3. So we have 8/3 z to the 3/2 from 1 to 4. So we have 8/3 times 4 to the 3/2 minus 8/3 times 1 to the 3/2. So 4 to the 3/2 is 8. So 8 times 8 is 64. So we get 64/3. 1 to the 3/2 is just 1. So we're subtracting 8/3. So that leaves us with 56/3. Number 11 is like one we've seen before. I'll do number 10, but I'm saying 11 looks like probably number 5. So probably we'll skip 11 too. But let's do 10. So we're integrating from -1 to 0 of 6x minus e to the x dx. So this should be 6x squared over 2. Remember, there's no constant up here with the x, so the antiderivative of e to the x is just e to the x. So that's the same as 3x squared minus e to the x from -1 to 0. And we just need to plug in. So 3 times 0 squared minus e to the 0 minus 3 times -1 squared minus e to the -1. Yeah, they're not letting you do decimal approximations, so we pretty much have to just simplify as much as we can. So e to the 0 is 1, so this will be -1 minus, and then we have 3 minus e to the -1. So we have -1 minus 3 plus e to the -1 when you distribute, which is -4 plus e to the -1. Or you could write it as a fraction, -4 plus 1 over e. Either way. Any questions on that one? Probably if you were simplifying using like 2.718, you might have been getting the answer wrong. So if they don't say to use a decimal, I guess you just have to simplify as much as possible. Okay, like I said, number 11 is pretty easy. I'll also get number 12. So integral from 1 to 64 of 1 over 2x dx. So remember, we want to think about this as 1/2 times 1 over x. So then we would know it would be 1/2 natural log absolute value of x from 1 to 64. These are both positive numbers, so the absolute value doesn't really mean anything, or it doesn't have an effect here. So it's 1/2 natural log of 64 minus 1/2 natural log of 1. And we know the natural log of 1 is 0. So this just simplifies to 1/2 natural log 64. That would be our answer. Okay. Number 13, this is pretty much what we went over the PowerPoint lecture. You're going over units. It's a multiple choice, so I don't really want to go over the answer too much. But remember, the units of this are going to be, that's the units of W prime of t times t. Okay, so take the units for W prime of t, the rate, multiply them with the units of t, which is time, and then that should be your answer in terms of units. So it shouldn't be a ratio, it should be a single unit.
Same thing with number 14. So I'm not going to go over those.
But I'll go over 15 and 16 because I was definitely asked about both of those. So number 15. So the marginal cost of a certain fabric, C prime of X, is that function, that polynomial. Find the increase in production from 2,000 to 4,000. So maybe if you were messing this up, notice it's total cost. It's not anything about average value. So this would just be the integral from 2,000 to 4,000 of 3 minus 0.01x plus, how many zeros I got there? 4 before the 1, 0.0000012 x squared dx. Okay, so again, we can find the antiderivative directly. It's just a polynomial, so it's going to be 3x minus 0.01x squared over 2 plus 0.00012 x to the third over 3 from 2,000 to 4,000. So we can simplify a bit here.
This will be 3x minus 0.005 x squared plus 0.1234, now fifth, 4 x cubed from 2,000 to 4,000. Okay, so I'm going to expand this a bit because it's going to be pretty big to plug in. So it's like 3 times 4,000 minus this number times 4,000 squared, this other really small number. Okay, so that's the first one. Then we need to subtract this guy. 3 times 2,000 minus 0.005 times 2,000 squared minus 1, 2, 3, 4, 5, 4 times 2,000 cubed. Right on the edge of the page. All right, that's as close as we can get. So let's plug each of these into the calculator and see how we do. I'll do each number separately. Okay, so this first set of parentheses, I get 188, 1, 2, 3. And then the second set, let's see what I get. Oh, notice there's a sign error here. There should be a plus. So I get minus 18,000. So that leaves me with 170,000. So let's see if that gives the right answer. Maybe the problem was just very lengthy and difficult to type in the calculator. Yeah, So we got it. I don't know, you know, it's a lot of decimal places and it's kind of hard to type in your calculator. So sometimes you just want to do it bit by bit. Did that make sense? Hide it with a repeating decimal kept making me wrong. Yeah. So I don't know if you can plug in repeating decimals. You might have to simplify your fractions. Did number 15 make sense for people that were asking questions about it? Okay, good. All right, let's look at the last one, 16. Average value function. So this one shouldn't be bad at all. So you just do 1 over 2 minus 0 times the integral from 0 to 2 of 6x minus x squared. So we have 1/2 times this antiderivative, which is going to be 6x squared over 2 minus x to the third over 3 from 0 to 2. So you have 1/2 times 3x squared minus x cubed over 3 from 0 to 2, and then just plug in your numbers. Probably since this has a third, you were using a repeating decimal too, is my guess, is the only reason you're getting this one wrong. So we've got 3 times 2 squared minus 2 cubed over 3, and then minus, when you plug in 0, everything goes away, right? So we don't have to really do anything there. So this one is 1/2. 3 times 4 is just 12 minus 8 over 3. 12 is 36 over 3. So yeah, getting practice with our fractions today. So we have 1/2 times 28 over 3, which is 56 over 3. So just a lot of stuff with fractions, it looks like. So you can't put in, what is that? 28.6 repeating or anything like that. Or no, not 28. 18. 18.6 repeating. That's not going to work. Okay, so let's try it. Oh, 56 over 3 says it's wrong. So did we mess up here? 36 minus 8, is that right? Oh, no. 28, yeah, that's right. All right, let's see. Did we make a mistake? 6x cubed over 3, 3x squared. This looks right to me so far. Oh, I multiplied by 2, not 1/2. Sorry, I had a moment. 28 divided by 2 is 14, so it should be 14 over 3. My mistake. There we go. Okay, so that's it for homework number 2. Not so bad, but just practice with those basic antiderivative rules. Does anyone have any questions for me? Okay, I'm gonna go ahead and end the recording.